So in this video, we're going to introduce the idea of a tree diagram and see if we can work out some probabilities using one. So let's just start by doing the basics. We've got a coin, it's tossed twice. We're going to list all the possible outcomes, but we'll do this with a tree diagram. So we start with the first throw of the coin. Okay, let's just say throw one, and we branch out like a tree in as many ways as there are outcomes. So when we throw a coin, we can either get a head or a tail. So there's going to be two. And then from there, what we're going to do is imagine what would happen on the second go. And the first two branches, we're going to think about these two here, are as if we had got a head on the first throw, right? So this is definitely throw two. But the two I've written down there, they are going to be just as if we had thrown a head on the first go. So again, we could get a head or a tail. These two next things down here, okay, come out from where the tail was, and these two are what could happen if we had got a tail on the first throw. And of course, we could still get a head or a tail. So this is a tree diagram, and if we follow the branches of the tree, we can see and reveal all the different possible outcomes. So for example, just following this blue line, head followed by head across there, that would be head, head. This one would be a head followed by a tail. This next one underneath will be a tail followed by a head. And then of course, tail, tail at the bottom. So these four different things here, these I should say, are the four different possible outcomes that could happen. We found them using a tree diagram. Okay, so let's go on now and extend this to probability and see how we can use another example to work out some probabilities. So, if the probability that it rains on any day is a fifth, draw a tree diagram and find the probability that it rains on 2 consecutive days and then that it rains on only one of 2 consecutive days. So if we start then and we say that let's have our first branches as day 1, right? So it is going to either rain or not rain. I'll use R for rain and NR for not rain, okay? And on day 2, we're going to have exactly the same situation. Now, if it rained on the first day, it can either rain on the second day or not rain on the second day. And if it didn't rain on the first day, it can still either rain on the second day or not rain on the second day. Okay, now once we are now introducing probabilities into this, we need to write them onto our tree diagram, and they go on the branches themselves. So as it says in the question, the chance of it raining on a certain day is 1 over 5. So I'm going to write 1 over 5 on this branch to illustrate that that is a 1 in 5 probability of happening. It's the same for every time we see this. Raining is a fifth on a certain day, so we can write that in all over the place. Okay, now if it's a fifth for raining, well, clearly the not raining is the complement event, so we can write that as well. It's going to have to be 4/5, so it adds to 1. And what you should find with your tree diagram is each particular section, for example, like that is going to add up to 1. This is going to add up to 1, that section as well. So you can check your tree diagram, as is this, to make sure each of the branches add up to 1, and if they do, you're doing it right. Okay, so finish this off. Let's work out the combined probability that it rains on 2 consecutive days. Well, that is going to be this top branch, isn't it? Rain, rain on both the days. Now, the way we work out that combined probability is we multiply those 2 probabilities together. They are independent events, and that means we can multiply them together. So we're going to have to do a fifth multiplied by a fifth. And of course, you should know how to multiply fractions. We multiply the numerators together, and we multiply the denominators together. So that is a 1 out of 25 chance of happening. Okay, so A, 1 over 25. Right, let's have a look at part B, and it rains on only one of 2 consecutive days. Now, it doesn't state the order there, so we need to consider 2 possibilities here, that it rains on the first day and doesn't rain on the second day, or that it doesn't rain on the first day, but it does rain on the second day. So we're going to need to consider 2 different branches of our tree diagram. So let's calculate them both separately and see what happens. So rain followed by not rain we're going to have to do a fifth multiplied by 4/5. So that's going to be 4 out of 25. And not rain followed by rain is going to be 4/5 multiplied by 1/5. And that, of course, is exactly the same thing again, 4 over 25. Now, I need to combine those because I'm only asked for if it rains on a day. It doesn't say if it's the first or the second day. So that means the way we're going to get around that problem is we're going to add these together. So our combined probability will be 4 over 25 plus 4 over 25, which of course is 8 over 25. We add the numerators. So the probability that it rains on only one of the two consecutive days is 8 over 25. Okay, final example, or maybe, sorry, penultimate example. The probability that Jenny is late for school is 0.3. Find the probability that on 2 consecutive days she is never late or late only once. Right, let's get started. We'll do this one nice and quick. Okay, we can see that she's either late or not late, late, not late, late, not late. So those are the branches of our tree. It tells us that that probability of being late is 0.3. So let's write that in, 0.3. So that means that not late was going to have to be 0.7. Now, I'm using decimals here because the question's in decimals, but you could use fractions just as easily. The first branches is day 1 again, and the second set of branches is going to be day 2. Okay, so never late is going to be this thing down here. So that is going to be 0.7 times 0.7. Well, that is 0.49. Late only once, well, that is going to be a combination of this branch and this branch. Late or not followed by not late, or not late followed by late. So we're going to do 0.3 times 0.7, which is 0.21. And we're going to have 0.7 times 0.3 here, which is also 0.21. So late only once is going to have to add these two things together. 0.21 plus 0.21, 0.42. So our answers for A was 0.49. Our answer for B, 0.42. Okay, this one really is the final example now. Okay, so Paul travels to London on the early train. The probability that he arrives late is a 1 in 10 chance. He catches the train on 2 consecutive days. Let's work out some probabilities. Okay, so same sort of principle as last time. He's on a train, all right? On the first day, he's either late or not late. And on the second day, he's either late or not late. And again, late or not late. So the probability that he arrives late is 1 over 10. So let's write that in everywhere. 1 over 10, 1 over 10, 1 over 10. So not late is going to be 9 over 10. 9 over 10, 9 over 10, and 9 over 10. So that is the branches of our tree diagram done. So what's the probability that he arrives on time both days? Well, that means not being late at all, which is going to be this lower branch. So we're going to need to do 9 over 10 multiplied by 9 over 10. Well, that's going to be 81 over 100. 81 over 100. On time at least 1 day. Okay, well, that's again going to be a combination of these two branches here. Let's try and work those out. We're going to have 1 over 10 times 9 over 10. Which is 9 over 100. And we are going to have 9 over 10 multiplied by 1 over 10, which is again 9 over 100. So we need to add these together to combine the two branches. So 9 over 100 plus 9 over 100 is going to be 18 over 100. We can simplify that down to 9 over 50. It's a good idea not to simplify the component pieces because it's easier to add them when you have the same denominator. But this one we can definitely write as 9 over 50. Right, late on both days, well, we can find that out as well, can't we? That's going to be this thing here at the top. We're going to have 1 over 10 multiplied by 1 over 10, which is 1 over 100. So we can write that in straight away there. Now, a couple of things to point out is that all of these 4 different probabilities and branches from the tree should, if we work them all out, add up to 1. And of course they do in this case. We have to have them all adding up to 1, so we've considered every different possibility that there is. Okay,